Assalamualaikum warahmatullahi wabarakatuh. So today we're gonna talk about the solar tracker system. So what is the solar tracker system is all about? In a easy way, solar tracker system is the solar panel that follow the sun. Whenever the sun go, it will follow. And the solar panel only can go into the forward and backward. So let's go to the next slide. So the main objective of this project is to develop a solar tracker system that have more efficient electrical energy absorption when compared to the fixed solar system. The research say that the solar tracker system have more efficient electrical energy absorb, 40% more energy absorbed compared to the fixed solar system, because the fixed solar system does not move or does not follow the highest intensity of the sun. It will stay constant on its own. So in this project, a various of component will be used. The main component one is the important one, light dependent resistor, or we call it the phototransistor. We use two LDR, LDR1 and LDR2. The next one is resistor. Give some resistance to the circuit. We also use two of the resistor that value 10 kilo ohm. And then next one is use the potentiometer. The function of potentiometer in this project is to control the value of the voltage and current. Next one is operational amplifier. So the operational amplifier in this project used to be the voltage comparator, because the op-amp compare the voltage of the input pin at number 2 and input pin at number 3, compare these two value of voltage, and the highest voltage value will selected and get to the output. Then we use two operational amplifier. Then we use transistor BJT NPN type and transistor BJT PNP type, E2 of each one. So the main one, we use motor as a load, and of course the power supply. We use the battery 9 volt. So let's see the circuit. So this is the solar tracker system circuit in the Tinkercad software. So the 9 volt as a power supply, and LDR1, LDR2 as the sensor of this circuit, and the potentiometer to control the value of voltage and the value of current. The next one is the op-amp itself. I use two op-amp. Op-amp will be used as the voltage comparator, and then the transistor NPN and PNP type will work as the switch in the circuit, and the last one is the motor itself. So in order to make the better understanding, let's see the table. So the table say that this is a table, the relationship between the LDR and the movement motor direction. So when the mode of LDR1 is high and LDR2 is low, which we label it as a mode 1, the motor movement direction would be a forward. So let's see the skirt. Run simulation, click on LDR1, put it on the highest, on the high ping, high condition, and LDR2 in the low condition, and as we can see, the motor move forward or move in the direction of the clockwise. And then I will explain the circuit a little bit. So when the LDR receive the light intensity from the interface, the sun, so at this point, at the low condition, the resistance of this LDR is very high. So when the sun, when it receives the light of the sun, it will go high, and automatically the resistance of this LDR1 in the very low. So when the resistance of the LDR is low, it will allow the voltage and current flow through the circuit. So the current will flow through the circuit, LDR and to the LDR, and potentiometer goes straight to the op amp, which is at the pin 3 type and pin 2 type, which is the 3 pin type is the non-inverting terminal, and the 2 pin type is inverting terminal. So let's see the voltage at this terminal. One, two, then connect the positive connection to the non-inverting legs and to the ground. Then this one, inverting terminal legs and the ground, and start the simulation. So as we can see that the value of the inverting voltage is higher than the value of the non-inverting voltage. So let's see the voltage of the output side. The point at the pin 6 on the ground. Set the highest pin, and then this is mode 1. The LDR1 high, LDR2 low. The voltage of the non-inverting will increase, and the voltage of the voltage of the non-inverting will increase, and the voltage of the inverting will is low, and you can see the output here. So this one is rotate or moving in the direction of the clockwise. So how about the mode 2? The mode 2 says that LDR1 at low condition and LDR2 high, so it will move backward. So let's see. So this is mode 2. Before we start the simulation first, and see the LDR1 is low, LDR2 is low, and the mode 2 say that the motor will move or rotate in the anti-clockwise direction. So we high, we give in LDR2 higher, and let's see the motor will move to the backward or anti-clockwise direction. You can see the voltage of the non-inverting terminal is higher than this voltage. It's the same, it's actually the same operational end at this section. So the output will be 6.37 voltage. We can control the voltage here, whatever value we want. And then the mode 3 and mode 4 is actually have the same output, which means the motor movement direction will stop. So how to give the motor, how to stop the motor. So LDR1 and LDR2 at the mode 3 is we have to put it the low, or the second option, the mode 4, which is we give the high condition on the both LDR1 and LDR2. So the motor will automatically stop. Let's see. Stop, run back. So this is mode 3 when the LDR1 and LDR2 is both on the low condition, and this is in mode 4, LDR1 in the high condition and LDR2 also in high condition. So as a conclusion, see the table. The mode 1 will move to the forward, and when it reach the enough intensity of the sunlight, it will stop, and the sun move back when the sunrise raise up, and will move backward using the mode 2, and the operation of the motor movement direction will repeatedly until the end. So this is a very simple circuit, solar tracker system circuit, that only use one axis, I mean the XY. No, it is. So that's all from me. Thank you.